Hello friends, welcome to EPG Pathshala. I am Dr. Ramaswamy Prasad from Department of Geography, Bhimrao Ambedkar College, University of Delhi, Delhi. First of all, let us discuss what could be the learning outcome of this module. While going through this module, you will be able to define composition and structure of atmosphere, enlist various gases and components of atmosphere, enumerate different layers of atmosphere, understand the significance of various gases of atmosphere, explain various layers of atmosphere and explain the importance of atmosphere as a living planet. Now, let us come to the meaning of composition of atmosphere. The literal meaning of the composition is ingredients or constituents of something. In other words, it is a manner by which something is made of. When we apply the same meaning with atmosphere, it signifies the items of the elements with which our atmosphere is composed. Our atmosphere is composed of numerous gases and other substances. Hence, it is a mechanical mixture of gases, water vapor and dust particles. Let us discuss about the composition of atmosphere. Let us discuss about the composition of atmosphere. The envelope of atmosphere around the earth, a mechanical mixture of numerous gases and other substances, are very important to all living organisms of the planet. The four major gases, nitrogen, oxygen, argon and carbon dioxide, together constitute 99.9% of the total volume of dry air. The maximum concentration of nitrogen with more than 78%, while the oxygen is little less than 21%. Nitrogen is the most abundant found in atmosphere, constituting 78.084% of the total dry volume of air. This is almost chemically inactive and have nothing to do with any sort of chemical actions of the atmosphere. It does not combine freely with other elements, hence it is termed a neutral substance. This gas is found beyond a height of 100 km, but its concentration is below 50 km height from the sea level. This gas is significant for the growth and reproduction of plants and animals. Certain bacteria in the soil are capable of converting a very small amount of atmospheric nitrogen into nitrates and fix it to the soil and water bodies to be consumed by animals and plants. This process is called nitrogen fixation. The nitrogen fixed in the earth's surface is again converted and sent back to the atmosphere by bacterial action through a chemical reaction called denitrification. Oxygen is the second largest gas of the atmosphere, constituting 20.95% of the total dry atmospheric gases. It is very essential for the survival of many of the living organisms of this planet. It is chemically very active gas. It is combined with several other elements and form various compounds. Oxygen is vital for combustion of fuels. When anything burns, oxygen is consumed and helps in burning that substance. Though oxygen is found beyond 100 km, but it is reasonably in good proportion within 16 km of height. With increasing height, the amount of oxygen decreases very rapidly. On mountain slope, the available oxygen for breath is very scanty and the mountaineers are supposed to carry oxygen with them. Argon. In terms of percentage, argon is the third largest gas in the atmosphere, constituting 0.934% of total dry atmosphere. It is an inert gas and chemically it is inactive. It is also found in the earth's crust and seawater. It is used in electrical bulb and fluorescent lights. Carbon dioxide. It is the fourth abundant gas of the atmosphere. It is densest gas and found in lower part of the atmosphere. It is found up to a height of about 30 kilometer. It is concentrated in the lower strata. Its percentage is very low, that is 0.04%, but it is most vital for the growth of vegetative life of biosphere. It is transparent to the incoming solar radiation, but does not allow to escape the same, and hence it is called greenhouse gas. It plays a very crucial role in increasing the global temperature. It is also known as variable gas, as its amount is dependent upon the combustion, human activities and vegetative cover of the planet. The carbon dioxide is reaching to the atmosphere due to several human activities like energy utilization, transport, industry, agriculture, waste generation, etc. Apart from these human induced sources, some natural sources are like plant respiration and release of air from stored carbon in rock through natural process of denudation. All these are leading to increase in the atmosphere. This gas is on rise with the advancement of economic development of the society. Economically developed countries, regions are generating big amount of carbon dioxide gases. Methane. Methane is a greenhouse gas which absorbs the radiation and cause more temperature of the air. Paddy cultivation also generates methane in the air. It is also produced from the wetland and waterlogged soils and released in the atmosphere. Fossil fuel is also a source of release of methane in the atmosphere. Its amount in the atmosphere is variable. There are numerous sources of methane. Ozone. Ozone's concentration lays in a belt between the heights of 15 to 50 kilometer of atmosphere. Instead of normal 2 atoms of oxygen, ozone has 3 atoms of oxygen formed together, which is denoted by O3. It is formed when atmospheric oxygen molecules are broken by ultraviolet solar radiation. It may even be formed at the time of electrical discharge during thunderstorms. This gas is also termed as variable, as its formation and disintegration is dependent upon numerous activities. Though ozone is very less in quantity, only 6 parts out of 1 lakh, this layer is very significant for the survival of living world, as it absorbs the dangerous ultraviolet rays and protects the earth. Neon, helium, krypton, hydrogen are other minor gases. Some gases are still extremely less in quantity and they are termed as trace gases. Important among them are ammonia, carbon monoxide, sulfur dioxide, nitrogen oxide, nitrous oxide and sulfur, etc. Water vapor. Water vapor is small in amount, but it is one of the most important part of atmosphere with respect to the distribution of vegetation and life. Water vapor exists all the time in the atmosphere, but with varying degree of amount depending upon the season and supply of water for evaporation and evapotranspiration. Air is hardly completely dry. In summer, the water holding capacity of the air is large as the temperature is high, while in winter it is low. Availability of sufficient amount of water on the earth's surface or water body in an area witness greater vapor, while less availability or avoidance of the same shows low vapor. Examples may be taken as equatorial region rich in water body, that is having high pressure, and subtropical hot desert region with less or no water availability, that has low vapor. Though vapor and air both are in gaseous form, Their mixing and movement are quite natural, but the same homogeneity it is not seen. At any particular point of time, the amount of vapor is not more than 4% of the total volume of atmosphere. It is found in the troposphere only, and its concentration is in the lower level. About 90% of the total vapor lays below 6 km. It is estimated that about 50% is within 2 km of height. Water vapor plays a vital role in keeping the earth warm, as it has greenhouse characteristics. Dust particles. Huge amount of dust particles are available in the lower layer of atmosphere in a suspended form. These dust particles are solid substances generated from various sources and being carried by winds. Greater velocity of wind have greater amount of dust particles. It is not only a matter of suspended solid particles, they are transported to great distances as well. They vary widely in sizes. They may be big size suspended only when the draft ability of the wind is great, but settles swiftly when the carrying capacity of the wind is reduced. You must have observed yourself too during gales or storms. Huge number of microscopic dust particles are suspended even in completely calm air. Dust particles are variable, and it is more during dry seasons, as the soil are loose and easily carried by winds. But reverse is the case when it is rainy season, when they are settled and compacted. Over the globe, it is less in equatorial and polar areas, while more in subtropical hot desert areas. Minute dust particles are found several kilometers above the surface, while the coarse sized are abundant near the surface. Microscopic particles are nuclei for condensation and precipitation, and they have great importance in this respect. Aerosols. Aerosols are extremely fine sized solid particles or liquid droplets which continue to be in suspended form in gas for very long time. They could be seen when their concentration is more, otherwise they are invisible. Aerosols themselves are non-gaseous microscopic substance released in the atmosphere from various sources, natural as well as human created. They could be pollen, minute earthly dust, sea salt, carbon soot from the burning fuels, volcanic dust, etc. Human activities also help the aerosols to enter the atmosphere. Their concentration is more over the industrial and urban areas. Burning of fossil fuels and generation of a smoke also pump the aerosols in the air. Therefore, the source of aerosols are both natural as well as human generated. They are grouped into two: hygroscopic, that is moisture absorbing and retaining, and the other one non-hygroscopic, that is moisture non-absorbing. Hygroscopic aerosols form the nuclei for condensation, and in this way they help in precipitation. From the above description, it is fairly obvious that our atmosphere is made up of innumerable minute molecules of several gases, about which discussion has been presented above. Apart from that, several non-gaseous substances are also available in the air, which are part and parcel of the atmosphere. They have their own significance and play a very essential role on the earth to be a livable planet. Now, coming to the meaning and structure of the atmosphere. A structure means the arrangement of different parts into one. In other words, it is the skeleton or organization or anatomy of a whole by looking at the relationship with its parts. According to this background, the study of different parts of the atmosphere and the relationship with its parts is said to be the structure of the atmosphere. Vertically, atmosphere is divided into different layers, parts. Therefore, the study of different layers is known as a structure of atmosphere. Now, coming to the structure of atmosphere. Based on chemical composition, the atmosphere is classified into two. They are homosphere and heterosphere. Now, let us see about the homosphere. Homosphere is that part of atmosphere where the chemical composition of the air is almost uniform or similar. It is the lowest layer in terms of chemical composition. It extends from the Earth's ocean surface to about 85 km. The density of air changes very rapidly with increasing altitude, but the proportion of the major gases found there remain alike throughout this layer, with the exception of water vapor, pollutants, ozone and some trace or very minor gases. On the basis of changes in the temperature, the atmosphere is divided into 5 layers. Out of them, 3 lower layers falls under homosphere, that is within 85 km of altitude. They are troposphere, stratosphere and mesosphere. Now, let us discuss about the troposphere. Troposphere is the lowest and densest layer of the atmosphere. It extends till a height of about 8 km over pole, but over equator it is 18 km. About 80% of the total mass of the atmosphere lays in this layer. With increase in height, the temperature keeps on declining till the limit of this layer. On an average, the decrease in temperature with height is 6 degrees Celsius per kilometer. The upper boundary is known as troposphere, lying between 8 and 18 km. At this level, the average temperature reaches to minus 50 degree to minus 60 degrees Celsius. Water vapor is found in this layer in abundance, and about 99% of the total atmospheric water vapor is concentrated here, but wide variation is seen in terms of height and latitude. Vapor plays very vital role in regulating the temperature of the earth by creating greenhouse effect. All weather phenomena are occurring in this layer only. Troposphere is the home of all types of clouds, atmospheric turbulence and mixing of the air. Both horizontal and vertical mixing is quite prominent here. In fact, the term troposphere is derived from the Greek word tropos, means turn. A sphere is signifying ball or a structure which is round in shape, attaining a 3-dimensional space. Therefore, troposphere is a 3-dimensional object with turning or mixing characteristics. Every sort of living life is confined to the biosphere, which include land, water and air. The upper limit of troposphere is tropopause, which is a transition between another upper layer known as stratosphere. Now, coming to the stratosphere. A stratosphere is the upward second layer as well as middle layer of the homosphere. It starts from tropopause to approximately a height of 50 km. The temperature at the tropopause remains almost constant till a height of about 20 km. After that, it starts increasing and continue the trend till the height of about 50 km. At this level, the estimated temperature is about minus 10 degree to minus 15 degrees Celsius. Though the temperature is on rise, but there is no atmospheric turbulence. This layer is completely free from clouds and other weather conditions. That is why it has an advantage of flying long distance supersonic jets, aeroplanes through this layer. The increase in temperature in this layer is caused by absorption of solar radiation by ozone, that is O3. Ozone is abundant in this layer and its 90% is concentrated in this layer only. The upper limit is the stratopause, which is a very narrow strip of transition zone beyond which mesosphere is found. A stratosphere is also termed as ozonosphere, a layer made up of ozone. This layer protects the living world of the planet from the harmful effects of ultraviolet rays. The ozone depletion and hole over Antarctic was discovered in 1985. Since then, we have observed that this layer has reached to a dangerous level of depletion of ozone. The main ozone depleting substances are received from the release of chlorofluorocarbon, that is CFC, hydrofluorocarbon, that is HCFCs, and carbon tetrachloride. When the molecules of chlorine atom come into contact with ozone, it turns O3 into O2, which is normal oxygen. One chlorine atom can destroy more than 1,00,000 atoms of ozone. Therefore, the chain of depletion is very serious. O3 turned into O2, an ordinary oxygen molecule is not capable of absorbing ultraviolet rays. Now, let us talk about the mesosphere. Mesosphere is the third but the uppermost layer of the homosphere. After this layer, heterosphere starts. The literal meaning of mesosphere is the middle sphere. It is separated by a stratopause below from a stratosphere and mesopause on the top from thermosphere. It is extended from 50 km to 85 km from Earth's surface. The air pressure is very low. It is 1 millibar at the lower limit, whereas it is 0.01 millibar at a height of the highest level. The layer is characterized by decreasing temperature, and the coldest lowest atmospheric temperature is recorded in this layer. The lowest temperature estimated near the mesopause is around minus 130 degrees Celsius. It is colder than the lowest temperature recorded over Antarctic. Between 75 to 85 km from the earth, noctilucent clouds are normal affairs in the summer nights between 50 degree to 70 degree north and south latitudes. Its literal meaning is night shining. It is deep twilight seen only when the sun is on horizon, but the sunlight is still falling at that height. The seen clouds are made up of ice crystal. Meteoric dust particles work like nuclei for ice crystallization, which are falling as well as produced due to burning of meteor caused by friction. Now, coming to the heterosphere. The atmosphere lying beyond the homosphere is termed as heterosphere. The term itself is self-explanatory, and it is used for that part of atmosphere where the air is not uniform. In this part of atmosphere, the air is rare and the molecules are wide apart. Relatively heavier gas molecules are concentrated in the lower part, whereas the lighter are forced to be above. Beyond 85 km height, the composition of the atmosphere with increasing altitudes varies significantly. The mixing of the gases are not possible as the turbulence is not happening there. Different layers of prominently different gases are nitrogen layer, oxygen layer, helium layer and hydrogen layer are differentiated. However, the heterosphere is divided into two spheres, thermosphere and exosphere. Now, coming to the thermosphere. This sphere extends from mesopause, that is 85 km, to about 650 km from Earth's surface. The temperature is on rise in this layer due to absorptions of solar radiation by a small amount of oxygen molecules present. It is highly dependent upon the solar activities. The temperature reaches beyond 1200 degrees Celsius at an altitude of about 350 kilometer, but by 650 kilometer it may even rise to 2000 degrees Celsius. This much high temperature is primarily defined by average speed with which molecules are moving. Because of this, the temperature may be high. The effectiveness of this temperature is not that great. Its exposure to astronaut, if they are coming out from their capsule, is not affecting at all. The aura is a conspicuous phenomena observed in this layer. It is a striking display of light and are maximum between 10 p.m. to 2 a.m. in the magnetic pole region of northern and southern hemisphere. It is known as aurora borealis in the northern and aurora australis in the southern hemisphere. They are referred as northern and southern lights. Charged particles coming from the solar flare reaches to the Earth's upper atmosphere. These charged particles collide with nitrogen and oxygen molecules present there in rarity. The collision results into innumerable little surges of lights. The scattering of these lights seen is very beautiful and magnificent. Now, let us talk about the exosphere. Exo means external. Therefore, exosphere is the external or the outermost layer of the atmosphere. Its lower boundary starts from the thermopause, that is 650 kilometer, to the limit from where the void space begins. The limit is estimated to be about 10,000 kilometer. This much of distance is little less than the diameter of the earth. It is really a very big size of the limit of the atmosphere. In exosphere, very light gases are traced and they are hydrogen, helium. Their molecules are spaced very widely beyond the upper limit of the exosphere. The space is considered to be void. Let us talk something about the importance of the atmosphere. Atmosphere is very crucial for every type of life surviving on the earth. Without atmosphere, there is least possibility of survival of living organisms. In very brief, following are the importance of the atmosphere. Atmosphere is made up of several gases. These gases are important for living world. Oxygen available in the atmosphere is the life of all animals, including human beings, for breath. Carbon dioxide gas helps in photosynthesis by plants, and plants are food for many animals. Without food, they are unable to live. Photosynthesis is not possible without the humidity of the air and soil. Hence, availability of water is also very important, and it is partly also found in the air in the form of vapor. The atmospheric vapor is distributed and redistributed all through the globe by hydrological cycle, but not uniformly. Nitrogen is equally very vital for making proteins through nitrogen fixation to plants and to all animals. It is the building block of the growth of body of all animals. Ozone is a protective layer of the atmosphere which traps harmful ultraviolet rays coming from the solar radiations. Its trapping in the ozonosphere ensures good health of all flora and fauna of the earth, particularly in the higher latitudes. Carbon dioxide, methane, nitrogen oxide, fluorinated gases, water vapor, etc. are responsible for keeping the earth warm. solar energy is reaching to the ground directly from the sun by short wave radiations, but when the earth radiates back the received energy to a space, it is being trapped by greenhouse gases. They keep the earth livable and maintain proper temperature. Without greenhouse effect, the average temperature would fall to minus 18 degrees Celsius, whereas at present the average temperature of the earth is 15 degrees Celsius. The difference between the two is approximately 33 degrees Celsius. We are able to hear any sound because of the presence of air in the atmosphere. It behaves like a medium to transport the sound waves. Flying of aeroplane is possible because of air, as it helps in flotation and marching forward the plane. Now, let us summarize our module. Our atmosphere is composed of several gases and other substances. The major gases are nitrogen, oxygen, argon and carbon dioxide. Some minor gases whose proportion is very low are methane, neon, helium, krypton, hydrogen, etc. and some other substances are water vapor, dust particles and aerosols. Their percentage in making the whole of the atmosphere is substantially variable. All of them are constituent of the atmosphere and are included in the constitution. The meaning of the structure is the arrangement of different parts into one. Therefore, a structure of atmosphere is different layers varying with altitude. It is primarily divided into two, homosphere and heterosphere, based on the homogeneity or the mixing of the air. Within homosphere, there are three layers: troposphere, stratosphere and mesosphere. The proportion of gases in these layers are almost uniform with height. All weather phenomena are occurring in the troposphere and temperature decreases with altitudes. The temperature keeps on increasing in the stratosphere because of absorption of solar radiation by ozone. Mesosphere witnesses the declining temperature, which reaches to around minus 130 degrees Celsius, colder than the Antarctic. Within heterosphere, there are two layers, thermosphere and exosphere. In these layers, gases are rarefied and molecules have very wide gaps. They are very light in weight and are having the stratification on the basis of their density. Relatively heavier gases are in the lower layer and lighter in the upper layers. The thermosphere contains the molecules of nitrogen and oxygen, whereas the exosphere have the molecules of hydrogen and helium. The atmosphere is very important to all living lives of the earth. It is possible only because of the atmosphere. The importance of oxygen, carbon dioxide, nitrogen, ozone, water vapor is immense for the survival of all kind of life. The greenhouse gases are maintaining a good balance to keep the earth livable. Thank you. Thank you very much.